Hey guys, it's Miss Hageman. I know I'm not with you today, but I have a video for you of the proofs that we did last week, and then I will provide you with some videos of the review slides at the end. So this is an introduction to proofs. There is a YouTube video here you can watch, and there was an ed puzzle we did on that as well, if you need a little bit of review. We did say that two-column proofs are like when we played Uno. What card are you going to play and why are you going to play it? And then you build up to a conclusion. In this case, we're proving triangles are congruent. This is a review question. In order to prove these two triangles congruent, this is not no information, okay? We are able to do this. We have to go in and we have to label a side for the reflexive property, okay? And then what you want to notice is as you go through, we had an angle here, okay? Those two are congruent there. Yes, that is a bisector, but that's not something that we're adding to the picture. That was already there. And we had a side here, and we had a side over here. Those were givens to us. Those are called givens. What we added was a side. And why did we add that side? Because anything that is in one triangle is equal to the other. And so that's called the reflexive property. And then as you read those triangles, that is side angle side. So you always want to be looking for more information that you know, and you can back it up using geometry as we get into these proofs. We have another one. You want to label what you have. We have two sides congruent in each. Those were called givens. We have another angle congruent in each. Those are called givens. Now we don't have reflexive property here because we don't have a part of the triangle that is shared. We do have a letter that is shared, letter A, right here in the middle here. Okay, that is not a bisector because you can clearly see that AD is longer than CA, all right? And AB is longer than AE. Okay, so we don't have a bisector. We don't have a midpoint. We don't have reflexive property, but we do want to focus our eyes on point A. So we either have vertical angles or alternate interior angles because we have two angles here. So those are not alternate interior because we don't have parallel lines. So these two angles are alternate interior angles. I'm going to mark those with two loops. I'm sorry, those two angles are vertical angles. I am very sorry, I misspoke there. Those are vertical angles, not alternate interior. Two angles across from one another are congruent. So you always want to look for where your triangles form an X. And now we have enough information for angle, angle, side. Remember, if one of the angles is pulled off of the side and that it's not next to it, but it's away from it, this would be angle, angle, side. The side is not between the two angles. For it to be angle, side angle, it would have to be BA and AD congruent to one another. So that's a review. So we added in vertical angles. This one's a little harder. Right now, this is no information. We only have one side given. And even using the reflexive property, that only gives us another side. Okay, so let's label what we have. We don't have any angles. We do know FE is congruent to FE, so that is a side. And then sometimes when you're labeling pictures, you have to look for something else that would have to be given to you, okay? We're looking for one more piece of information that would have to be given to us in order to prove this, because right now this is not enough information. We've already added in the reflexive property, so we either need another angle or another side, okay? What we want you to notice is you cannot be given angle DEF and FEG, because that is not a congruence theorem. That is SSA or ASS. So we're going to eliminate that. And we also cannot be given the corner angles. We can't be given angle D and angle G because that spells the same thing, ASS or SSA. So the only thing you can be given here is the two angles around F. We don't know they're 90, so we cannot mark that box in there, okay, for side angle side. But that is not a choice here, okay? This angle, that was the top angle that we did, and that was the corner angle. So they do not give us the two angles around vertex F as a selection. So we're going to have to go with just DE is congruent to GE. So that would have to be provided to use the side, side, side theorem. Had they given us the angle around F, maybe it's 90, maybe it's not, we could have used side angle side. But in this case, for this question, we have side, side, side. So if you were kind of looking at angle F as needing to be provided for side, side, or side angle side, you were going in the right direction. It just was not a selection for us there. So that is side, side, side. All right, now we're going to go through some proofs, and this will help you with your assignments for this week. So angle YLF and angle FRY, those are stated to you as givens, and we are also given something else. So your givens always go first. So I'm going to type the two givens in the proof. It's hard to type these angles. You can just highlight it, Control C, Control V. And so we're going to mark those angles in the picture. So we'll start with the first one. Angle YLF is congruent to angle FRY. L and R are your middle letters, so those are your that's called your vertex. So we mark an angle there. And then the other given they gave us is the two angles around point F. And make sure those are in your same triangle. Okay, so they gave us angle RFY. I do two loops on that one, is congruent to angle LFY. Kind of looks like a cool little paper airplane here. And so those are our two angles there. Okay, we're not going to say that's a bisector here because that's called a given. Okay, those two angles are congruent, but whenever you're given something, don't go and continue to say what those are. Just say that they're given. Okay, so those are given. And then we need another piece of information that is not here for it to be enough information. Okay, so you want to notice we have a shared side YF, and that is going to be your last piece of information for the proof. And anytime you share a side, it's called the reflexive property. You can also share an angle. We haven't seen that yet, but you can share an angle as a triangle. So those are two sides. Make sure you type that or copy that. Control C, Control V in your proof. That's called the reflexive property. Okay, so you can see the buildup of the proof of what we've been doing before. And now instead of selecting an answer, we're just labeling our diagram, filling out a proof so we can specifically say where our two angles are and what our side is. So we have our two angles that were given. We have our side that is not between those two angles. So this is angle, angle, side. Whenever your side is not between the angles, notice the blue one is not touching the purple, it's going to be angle, angle, side. That's the difference between that one and angle, side, angle. So there's your picture. And go ahead and pause and write that down. And then we have our proof filled in. Make sure you have both. Proof number 2. There's a little tiny mistake on here with a step that is missing, but we will get through. So the first two are always given, so make sure you have those, and then we're going to mark them in the picture. T is the midpoint of KY, and they will be in your word bank as well. How do we mark parallel lines? We do not use tick marks, we use arrows. So I'm going to do a zigzag. I'm going to say these are going up, and we will come back to the alternate interior angles. So that's one given. That's going to give us alternate interior. Our other given is T is the midpoint of KY. And so T is the midpoint of KY. So from K to Y, make sure you just mark these two sides. And that actually is the piece that is missing in the proof. We need to actually state these two sides. And so I'm going to add it as a text box. So this would be in the proof. We cannot edit this, though, after creating it. So KT is congruent to YT by the definition of midpoint. And when we say by the, that just means the reason. Okay, so that was missing. I'm going to draw an arrow that goes up in your proof. And that should have been in there. And again, I can get a congruent symbol here. Control C. So KT, you can say is equal to YT, or you can say is congruent to whichever symbol you have by the definition of midpoint. So that should be in our proof. Sorry about that. I'm just going to draw an arrow. So that should be up there in our proof. All right, so now we have our givens labeled, okay? We have another set of angles that's very important, forms like a bow tie. Okay, these are called vertical angles. Check your word bank, you do have those. So we have 2 loops here. Oh, we could just do 1 loop. And we have an A for angle, and those are our vertical angles. And you want to notice they name them for us in the proof. Sometimes we'll name things for you and help you out. So angle ATK was the angle on the left, and angle HTY is the angle on the right. And those are vertical angles. Those are congruent. And then we do have alternate interior angles that we are coming back to from the given. Now you could have done those before the vertical angles. A lot of times if you move a row up and down, you want to move the entire thing. You want to move the reason with the statement. So we could have switched vertical and alternate interior as long as we switch the angle order as well. So the alternate interior angles are right here. Angle AKT is congruent to angle HYT. And you'll notice that that's the same as just saying angle K and angle Y. So you could name those with 1 angle. If you were writing your own little proof here, I'm going to mark those with 2. So those are our alternate interior angles. Okay, so make sure you know that a step was missing from the proof. My apologies. We have vertical angles. We were given parallel lines, which we had to know that alternate interior angles were there. And we had no vertical angles. And we had a bisector. So that lined up, angle, side, angle. The side is between the 2 angles. And then our last proof. Always put your givens in. Control C, Control V. We're going to go through and mark those. We have C is the midpoint of BE and AD. It'll be very important that we mark both of those. Okay, so let's go through here. We have a tick mark for BA. It's a side. We have another tick mark for DE. It's another side. That was given. Always mark your givens. And then we have C as the midpoint of BE and AD. So we'll do the first one. We'll do BE first. So C is in the middle of BE. So we know that BC is congruent to CE, and that was already in the proof right here. And we know those are congruent by the definition of midpoint. And then we can't do vertical angles here because that would spell SSA or ASS. You want to look for where it says and AD. So you want to carefully read your givens. It also intersects AD. And so that's a piece that you want to have. Once you see that, and you were writing your own proof, you could do vertical angles if you wanted to do side angle side. That's up to you. But if a proof's already set up for you, we'll usually give you what you need in the word bank. But if you did vertical for SAS here, that would be correct. In this case, we're going to skip the vertical here, and we're going to do side, side, side because of one of the givens they gave us. Had they not given us BA and ED, we could have done side angle side. So in this case, we have SSS. Whoops, I am skipping a step. I am going way too fast. Sorry, guys. Let's state the one with the 3 tick marks in purple. AC is congruent to DC, and that's definition of midpoint as well. Copy that. Control C, Control V. And then we have our side, side, side theorem. Again, you could do side angle side if you were creating your own proof and writing your own rows. You could do side angle side with vertical. So that was the 3 proofs from last week.